Hey guys, welcome to this topic's video. It has to do with a table and looking at the linear relationship of water level in a tank and time. So the question is, based off of this information, what's the rate of change of the water level in feet per hour? So I just thought this would be kind of a good opportunity to talk about our different representations that we teach in high school math and how we could um, maybe connect all of the relationships or the representations together kind of in one space, sort of, or using GeoGebra basically to help us kind of do that. And if you have other tools like smart software, cycling between writing and graphing and all that, but you can also write on top of GeoGebra. The pen tool is just kind of a little not that good, I guess. Smart Ink will write on top of, GeoGebra too. Um, but anyways, just kind of show how we can kind of connect the representation. So we have this table. So in GeoGebra here, I just took the picture in the table and just put it in here so we have it for the video. So we can definitely do our table investigations, look at the difference in time is 2 hours, the difference in water level, one, it's going down, and it looks like we're just subtracting 10. So, you can get to where you're subtracting 5 feet per hour, and that really answers the question. But let's do a little bit more. What does this look like as a graph, and how do we write this pattern as an expression? So I think that GeoGebra does a pretty cool job in doing that. So I'm going to first I want to whenever you put a picture, even though this isn't part of the video or whatever, but just talk about pictures in GeoGebra. If you zoom in and out when you put a picture, the picture is based off of points that have a location. So when you zoom in or out, it affects, the scale of where our points are, which makes our picture then shrink and grow. If you want a picture like this to sit in a spot and not move, then you have to use this absolute position thing here. So make sure that your picture is selected and then just click absolute position. Now, no matter what, as we zoom in out, you can see the points moving, but now the picture doesn't depend on those. And then you can just hide those points by right-clicking point and then just going to show object, and that'll select both points we have. Okay, so here is our info. Let's create a table so that we can see the points. Let's look at the graphical representation first of all. So when I use spreadsheets in my classroom, I tell my students it's the electronic table. So if we open up the spreadsheet, we're just going to reproduce this table electronically so we can use it. And without putting in the time and the water level, I'm just going to start with 0, 2, 4, 6, and put in the feet. Okay, so now what we can do, and I'm going to hide this picture now. So now we can actually graph these points. So I'm going to click on my first cell here, click and drag and select all my data. My options now, my tools are spreadsheet and stat options. So one of the things in the third toolbox here, this create list tool by default, we don't want to create a list, but if you hit the down arrow, we can go to create list of points. So if we click on that, we get a little preview window. You can name your list whatever you want. You can change the order. You can do the inverse if you wanted to. I always like to look at this and tell my students when we do this, make sure you look at your preview and that you have the correct relationship you want. So 050, 240. So we're good. I'm going to hit create and nothing's really happened. So I should probably take a look at what my grid and my axes are set at here. So we should have my Y max that I'm looking at here is looking like 10, and we need to get all the way up to 50, and the first point's up to 20. So we can change the scale of an axis. If you zoom in and out like this, notice it affects both grids, right? And then we can take a look at our data here if we wanted to. Or what I like to do, I'm going to go back to the standard view. So you can just right click in your screen and go down to standard view if you ever need to get back to where you start. So all your students maybe can kind of, if they're out exploring, can kind of all recenter somewhere. One nice thing you can do, if you have your Move Graphics View tool selected, Or even if you have a different tool selected, hold Control on your keyboard, which will turn your tool into the Move Graphics tool. But if you have that tool selected or you have Control pushed down, you can hover over the Y-axis and then click and drag your Y-axis down to the origin, and it'll change only the scale of the Y-axis, which I think is pretty cool because it's not affecting our X-axis at all. Just changing the scale of our Y-axis. So this is now going by tens, which is perfect. So now we can see the graphical representation of our table, right? And we can see that it's linear, that it's going down as time is going on. You could ask questions now of where do you think, this pattern will equal 0, right? All that good stuff. When you talk about your expression, so I'm going to grab the pen tool. It's in the text toolbox here. So if you talk about your expression and why we need to find slope, it's going down 10 feet for every 2 seconds. So you could even talk about, well, how far down in 1 second, right? Which is our slope. So they'll see that it's -5. So now our expression should just be -5x plus 50 where it started. So here is our expression of how to represent this pattern here. So now we can start asking questions. Well, what's the level at 8.2 second or hours or anything like that? You can do a more of a function kind of idea once they have their expression made. So now they can put the -5x plus 50 into their input bar down at the bottom, and when they hit enter, you can see our equation go through our points nicely, and you can go and see that it's going to cross at 10 hours. There'll be no water left and all that good stuff. Okay? But just kind of a cool, unique opportunity, I think, to take a relatively simple question, but I think you can see how you can make a really enriched lesson with GeoGebra as your good visual tool. Okay? Hope that made sense, guys. Enjoy.